See, now learning names of first 20 elements of the periodic table. In the previous class, I have given you the definition of atomic number. It is the number of protons present in the nucleus of an atom. So atomic number 1, we will start with this element is hydrogen. Atomic number 2 is helium. These all names of the elements with their atomic numbers, with their electronic configuration, as well as their valency. You need to learn them by heart. So I'm going to make you learn this in the form of story, which is going to make you easy to remember the names of these first 20 elements. So we start with atomic number 1 and atomic number 2. You remember hi, hello. Hi, hello. So this is atomic number 1. Atomic number 2, this is hydrogen. The second element is helium. Okay, now first orbit cannot have more than 2 electrons. Because here the atomic number of hydrogen is 1, it will have 1 proton. So the number of electrons that will be present will be 1. So that 1 electron will come in the first orbit. The atomic number of helium is 2. So there are 2 protons, so there will be 2 electrons. These 2 electrons, we are going to place them in the first orbit. So the electronic configuration of helium is 2. Now we talk about valency. Valency is the combining capacity of an element. The first orbit cannot have more than 2 electrons. Hydrogen is already having 1 electron over here. In order to make 2 electrons in the first orbit, it needs 1 more electron. Therefore, valency of hydrogen is 1. The first orbit cannot have more than 2 electrons. 2 electrons are already present in helium. So it doesn't need any electrons. There are already 2 electrons in it. So the valency of helium is 0. It means it is going to be an inert gas. These were first 2 elements. I'm going to give you the story in order to remember the next 8 elements. See what the story is. Remember this story. We start 1 and 2 is already done. Atomic number 3, 4, 5, 6, 7, 8, 9, 10. These are number of protons, that is, these are the atomic numbers, also equal to the number of electrons. The names of these elements. In order to learn the names, you remember lily belly, bought cashew nuts on Friday night. I'm repeating, lily belly, bought cashew nuts on Friday night. These are the atomic numbers, that is number of protons, also equal to number of electrons. So now we are supposed to put the electronic configuration. Remember, in the first orbit we are always going to have 2 electrons. So 2 electrons we have put, total number of electrons is 3. So therefore that 1 electron which will be there, it will come in the second orbit. So the electronic configuration of lithium is going to become 2, 1. Similarly, now here the electronic configurations, we can continue. This will be 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, and 2, 8. See, when you are adding this, you are going to get the atomic number, that is number of protons also equal to number of electrons. The first orbit will always have 2 electrons. The remaining electrons which are there, that we have put them in the second orbit. So this is the distribution of electrons, that is the electronic configuration of next 8 elements. I am repeating that part of the story once again. Lily Belly bought cashew nuts on Friday night. What are the names of these elements? This is Li, that is lithium. Be is beryllium. B is boron. C is carbon. N is nitrogen. O is oxygen. F is fluorine. Fluorine is Fluorine. And the last one is neon. So this is the list of next 8 elements. We have arranged these electronic configurations. Now the next part that we are going to come to is its valency. Because here first 4 elements, 1, 2, 3, 4, these are the number of electrons that are present in the first 4 elements. So their valency is going to be, of course, it will be positive. It will be 1, 2, 3, 4. These are going to 1, 2, and 3. This can give away 3 electrons, so their valency is 1, 2, 3. Carbon will share 4 of its electrons, so its valency is 4. Now here for next 3 elements, 5, 6, 7. They cannot give 5, 6 or 7 electrons, but here this can take 3 electrons, so 5 plus 3 will become 8. This will take 2 electrons, so 6 plus 2 will become 8. Remember, all of them have to make 8 electrons in their outermost shell. This can take 1 electron, so its valency will be 1. So here now the valencies are going to become 3, 2, 1. This is already having 8 electrons in its outermost shell. It is already stable. It doesn't need any electrons. Therefore, its valency will be 0. It is going to be an inert gas. These are the list of first 10 elements of the periodic table. I just want you to take down all of these elements and then we will go for the next 10 elements. So we have done the first 10 elements of the periodic table. Now we will take from 11 to 20. The next one is starting from 11, 12, 13, 14, 15, 16, 17, 18. Okay, so this is from 11 to 18. These are the atomic numbers, that is number of protons also equal to number of electrons. How do we remember this in same order? Now here you remember the story. Na mango Allah si paisa sona chandi aram. I am repeating this phrase once again. Na mango Allah si paisa sona chandi aram. NaMgAlSipSclAr. Na is sodium, Mg is magnesium, Al is aluminium, Si is silicon, P is phosphorus, S is sulfur, Cl is chlorine, and Ar is argon. We are supposed to put 11 to 18 electrons and arrange them in the form of their electronic configuration. The first orbit can have maximum 2 electrons. The second orbit cannot have more than 8 electrons. How many electrons are remaining? 2 plus 8 is 10. From 11, 1 is remaining. So the electronic configuration of sodium will become 281. Same way we just have to continue over here, 282, 283, 284, 285, 286, 287, and 288. So this is how the electrons will get distributed in atoms from sodium to argon. These are the electronic configurations. The last part is the valency. Again, the valency will come in the same way as we have done over here, because here the number of electrons are 1, 2, 3, 4, 5, 6, 7, 8 in the last orbit. This will get rid of 1 electron, so valency will be 1 plus, this will be 2 plus, this will be 3 plus. This will share 4, so valency is 4. This will take 3 electrons, so valency will be 3 minus, 2 minus, 1 minus. It already has 8 electrons, so valency will be 0. In the same way, same thing is going to come for all of these. We'll have valency 1, 2, 3, 4. And then finally here, 3, 2, 1, 0. Okay. So now you can see over here, chlorine is having 7 electrons in its last or outermost orbit. Because it needs to make 8 electron in the last orbit, it will take 1 electron from someone who is ready to give, and therefore its valency is going to be 1 minus. So here I just have to subtract. 5 minus 8 is 3 or minus 3, minus 2, minus 1. Here already 8 are there. It's an inert gas. It will be non-reactive, so its valency is 0. This is the first 18 elements that we have discussed. The next 2 elements that are there, you simply remember Kaka. This will be 19, this will be 20. K is potassium, Ca is calcium. The electronic configurations, you can't put, okay, here 19 are there, so you may be thinking of putting 289. This is not possible because we cannot put more than 8 electrons in the last orbit. So here the electronic configurations will become 2881 and this will become 2882. Okay, obviously here 1 electron is there in the last orbit, so its valency will be 1 or plus 1. This is having 2 electrons in their last orbit, so its valency will be plus 2 or 2. We have done first 20 elements. I have recorded the class and I want you to revise this part again and again. I'll just ask you to copy this down and then we'll go to the next part.